Hey, how you doing? Today we're going to look at linear equations in two variables. Now this is a topic that is really a quickie skim over. You've done this in Algebra 1, you've done it in Geometry, you've done it in Algebra 2. I kind of expect you to know this, so we're doing a quickie overview. If you feel like, wow, I'm kind of weak in this, I need a little bit more than a quickie overview, I have some additional videos in your list of videos up at the top. It'll say, I forgot how to write the equation of a line, or those kinds of things. And so go there if there's anything here that I cover too quickly for you. Okay, so first of all, I want to talk about using your graphing calculator for this. All right, so it's hard for me to kind of show graphing calculator stuff on this type of a video, so that's why I have additional videos on how do you make a scatter plot, that kind of stuff. So go to your list, look at that. But this was the one we did in class. And so what we did, and what I would expect you to be able to do, is enter this data. And so you would go to Stat, Edit to enter data. So I'll write that up here. You go to Stat, Edit to enter the data. Okay, to make the scatter plot of it, you would go to second y equals, which is your stat plot, and you go hand pick all the features that you want. You'd want to use a scatter plot using list 1 and list 2 and so forth. All right, the next thing you would have to check is your window and make sure that it is appropriate, because this would certainly not fit in a standard 10 by 10 window. So you got to tweak your X-Men and all that business to match the data in our table. Okay, to find the equation of your, okay, and then you would, once you did that, you should be able to graph it and see the scatter plot. And then our goal would be to write this equation of a line, which is kind of what our focus is in this section, is writing equations of lines. So to do that, it really depends on the type of calculator you have. And so you can look at my earlier videos, or if you just want to Google a YouTube video, how to write, it's called a regression equation, but how to write that for your particular calculator. And you could easily find a YouTube video that'll show you how to do that. In general, you would go to Stat, Calc, and then you would typically pick 4 for a linear regression line, since we're doing a best fit line. And then at some point you got to get that equation put into your y equals. Again, that would vary quite a bit based on what calculator you have. And you graph it, and it should graph on top of it. Okay, so that's kind of what we did in class. You need to be able to do that as well. Let's go look at it, doing it a little bit more algebraically. Okay, so before we get too far into trying to write equations, let's review some things. Let's talk about slope. You will need to know how to find the slope. So remember that the slope of a line is equal to y minus y over x minus x. So that's our formula for slope. You need to remember that horizontal lines have 0 slope. Vertical lines have undefined slope. You may or may not have learned that little acronym HOIVUX. I kind of like that. HOIVUX. Oops, can't spell. And you would need to be able to spell it in order for it to make sense. Okay, it says that horizontal lines have 0 slope, and their equations always look like y equals a number. So like y equals 4, y equals 7. So that's horizontal. You need to know that vertical lines have undefined slope, and their equations are always x equals a number. Okay, so if you can remember this little acronym, or just know what the slope of a horizontal or vertical line is and how to write those equations. Okay, next thing, we need to remember that parallel lines have the same slope, and perpendicular lines have the opposite reciprocal slope. So for instance, if one equation had a 3/4, its perpendicular line would be negative 4/3. It's the opposite sign, and you flip the fraction. Okay, and then the last thing that I wanted to refresh your memory on is what slope-intercept form is, because that's typically how we write our equations, in slope-intercept form. So that'd be y equals mx plus b. Okay, so let's use that and review a little bit, do a couple problems. Okay, so here's one. It says write the equation of a line that passes through 2, 1, and it's perpendicular to 4x minus 2y equals 3. All right, so to write the equation of a line, we need to know the slope and the y-intercept. They didn't tell me either one of those things. So here's what I'm going to do. I'm going to go to my y equals mx plus b. And I really wish I knew the slope, but I don't. And I really wish I knew the b, the y-intercept, but I don't. But they do tell me that it's perpendicular to this line right here. Well, remember, I know something about perpendicular lines and their slopes. So what I'm going to do with this equation right here is I'm going to rearrange it, and I'm going to get the y by itself. So let's subtract the 4x. I got negative 2y equals negative 4x plus 3. Now divide by negative 2, everything. And so y would be equal to 2x minus 3 halves. All right, so that's the equation of this line when I put it into slope-intercept form. This is nice standard form, but I really need it in this form because looky, there's the slope. The slope of this equation is 2. That's all I'm going to use. The slope is 2. I don't want anything else out of that equation. Now, if my line over here was parallel to this, I'd use a slope of 2. But my line is perpendicular. So I'm not going to use m equals 2. I'm going to let m equal negative 1 over 2. And then I'm going to grab that point, that 2, 1, and that's really an x and a y value that should work in my equation. So what I have now for this equation, I have an m, I have an x and a y. I can go find my b because I know everything else. Okay, so let's go do that. Plug 1 in for y, negative 1/2 is my m, take it times the x, which is going to be 2, plus b. All right, so 1 equals a negative 1/2 times a 2 over 1 is going to end up negative 1. Add 1 over here, so b ends up equaling 2. So now what I have is b, my y-intercept is 2, my slope is going to be negative 1/2. Let's go write our equation. Y equals negative 1/2 x plus 2. And that's the equation of our line. So your goal when you're writing these lines is always somehow get around to finding a slope and a y-intercept. And there's a lot of different things that they can give you, but that's what you're working towards every time. Let's try an application problem here. It says create 2 points from the scenario and then write the equation. So this will be an example of how to write the equation of a line if you know 2 points. But I threw in an application where we have to figure out the 2 points. So we have a real estate office that handles an apartment complex with 50 units, or that's 50 apartments they have. When the rent per unit is $580, all 50 units are occupied. However, if we up the rent to $625 per month, then the average number of units drops to 47. So it's kind of pricey, so we can't really rent them all. We have a harder time getting people to rent our apartments that way. Now, assume the relationship between monthly rent, R, and the demand, D, is linear. It says write the equation of a line giving the demand in terms of the rent. Okay, so really that's just write our equation, y equals mx plus b, but instead it's going to be like a D in terms of the rent, so it's going to be mr plus b. So we're going to have a D and an R instead of an X and a Y. That's what they want. Okay. So here's the deal. they basically have given us enough data to write two ordered pairs. Now our X is kind of like our R, or our rent, so I'm going to write an ordered pair that goes rent, comma, demand. And I actually have two of those. Originally, if I charged $580, I would have all 50 units rented. But I also have an ordered pair that says if I charge $625, then I'd have 47 units rented. All right, so I have turned this into two ordered pairs. Let's go write the equation of the line. Now, what I have here are two x and y's. I got an xy, xy. I don't have a slope, and I need that, and I also don't have my y-intercept. But I think I can find slope. Let's use our slope formula, and let's do y minus y over x minus x. So I'm going to do 50 minus 47, y minus y, over x minus x. Okay, so let's simplify that. That's going to give us a 3 over negative 45. If you want to go decimal on that, that's okay. Probably would in a problem that's like this. So let's take our 3 and divide it by 45 and see what we get here. All right, not beautiful, but I can work with it. It's a 0.067 is what I'm going to go with, and it is a negative. Okay, so that's a negative slope. So if you think about this, well, let's go ahead and find all of our information, and then we'll talk about what everything means. So now I know the slope. I don't know my y-intercept, but remember what we did last time? If you knew the slope and you knew a point, you could go find the b. And I can use either one of those points. So let's go find the b. I'm going to use the m of negative 0.067. I'm going to use the 580/50. So I start off with y equals mx plus b and fill in. Y is 50. M is negative 0.067. X is 580 plus b. So in my calculator, and I kind of like to keep that whole number in my calculator since I've got it, I'm just going to take that times 580. So that ends up being negative, let me clean that up. It's not a z, it's an equals negative 38.6 repeating plus b. So let's add the 38.6 repeating, and then I'd end up with 88.6 repeating equals b. So the equation of my line becomes, I'm going to come over here on the far left, the equation of my line, and instead of an x and a y, I'll put my d and my r, so it'll be a d equals, the slope that I found was negative 0.067, and instead of putting an x, I'll put an r for the rate or the rent, plus the b that I found, which is 88.6 repeating. How about if we go 6.7? All right, so this is the equation that represents the rent here. Now let's talk about what the questions they have. It says use this equation to predict the number of units occupied if the rent is $655. Okay, that's easy enough. I'm going to put 655 in for R. So in my calculator, I just write negative 0.067, I'm going to round that off, times 655, and then add in the 88.67. And I end up with a demand, then, of 44.7 units. Actually, it'd be 44.8 units rented. Okay, so if I make the rent $655, I'm only going to be able to rent 40, let's round that, we'd probably round that up to say 45 units I'd be able to. So I'd have 5 units empty when I do that. Okay, now the other part of this question was, how much money would the real estate company make per month? Okay, they're charging quite a bit. Now, they do have some open units, but if you charge $655 a month in, let's say, 45 units, how much would you make every month? Well, I don't know. I got $655 times, I'm rounding up to 45 units that I can rent. All right, I end up making then $29,000, well, $29,475 every month. Okay, so it's kind of a balancing act as the real estate office is trying to decide, how to make the most money. Should they up the price and make it expensive and not quite rent all of them? Or maybe they should make it cheaper. So we're going to try it again. We're going to make it a little bit cheaper and see if we can't get more rentals rented, and maybe that would help us make more money. Maybe not. Maybe we'll make it too cheap and then we're not making money. Okay, so I want you to try it again. So instead of doing the $655 to get 45 units rented and to make this much money, you do the same thing now with $595 and compare it and see if that's a better deal. Pause the video. I'll wait for you. All right, this is what I got. When I put $595 into the function for the rent, I got back a demand of 48.8. So I rounded that to 49 and said, all right, I'm going to be able to rent 49 units. Took 49 times $595, came up with this amount that I'm going to make every month. That's actually a little bit less. So I'm really better off to charge a little bit more and not rent all the units. I'm still going to come out ahead in money. Okay. All right, so that's kind of a nice application of why we might want this equation and how it can help us to, well, in the end, let's make some money. Okay, let's try one more problem. Okay, this is very similar, so I'm going to cruise through this pretty quickly, but you do have a problem just like it on your assignment, so pay attention. It says a business purchases a piece of equipment for $875. After 5 years, the equipment will be outdated and have no value. Determine the 2 points that you would use to write this equation. Well, I'm going to kind of help you. We're going to do the 2 points, but I'm going to go ahead and write the equation as well. So, my 2 points. The things that I have going on are time and the value. So, I'm going to do time value as my ordered pair. So my 2 points are when I originally bought it, so at time 0, the value was $875. 5 years later, it had no value, so I'd have an ordered pair of 50. So there's my 2 points. Let's go write the equation. So we did this last time. You had 2 points. First thing you're going to do is find your slope. So remember that that's y minus y over x minus x. So the slope would be, I'll do 875 minus 0 over 0 minus 5. So 875 over negative 5 gets me a negative 175 for slope. Okay, next thing I'm going to do is grab one of these points, either one. I'm going to pick the one with smaller numbers. So there's my x, there's my y, here's my m. Let's go write the equation. Y equals mx plus b. So the y value is 0, m is negative 175, x is 5, plus b. So I'm basically taking my negative 175 times 5. And so 0 equals negative 875 plus b. Add the 875 to the other side. I get an initial value of b for b of 875. But look, doesn't that kind of make sense over here? That it initially cost $875? Yes, okay, so that should make sense to you. I went through the algebra, but, it's a little bit of common sense there as well. So my equation then becomes y equals negative 175x plus 875. And so you could start plugging in numbers. It doesn't ask anything on this one, but they just want the equation, so we just wrote that. But it's kind of important to understand what's going on. Your y-intercept is always your initial value, so it was initially worth 875, and your slope here is your rate of change. The fact that it's negative tells me that the value is going down, which makes sense. The value does go down. And what it's doing is it's going down $175 per year, because our units for time were in years. Okay, hope this helps you. Good luck.